Our next plenary speaker is Ming-Kai Tsai, who is the chairman and CEO of MediaTek Incorporated, a leading fabless semiconductor company established in Taiwan in 1997. Under Dr. Tsai's leadership, MediaTek has grown to one of the top 3 fabless semiconductor companies in the world and is the only top-listed fabless semiconductor company founded and headquartered outside the United States. Dr. Tsai received his BS.EE from National Taiwan University and MS in EE from University of Cincinnati. In his early career, he incubated and developed Taiwan's first IC design industry at the Electronic Research and Service Organization in Taiwan's Industrial Technology Research Institute, and thereafter at United Microelectronics Corporation, where he held various senior positions. In 1994, he was made president of UMC Business Group II, which produced chipsets for consumer and multimedia products. 3 years later, the division was spun off and formed into what is now MediaTek. In 2013, Dr. Tsai was recognized among the 100 best performing CEOs in the world by Harvard Business Review. He has received various awards for his achievements, including the ITRI Laureate Award, honorary doctoral degrees from National Tsinghua University and National Jiaotong University, and the Distinguished Graduate Alumni Award from National Taiwan University. Please join me in welcoming Chairman Ming-Kai Tsai.
Good morning, everyone. It's my great honor to speak at this prestigious conference from an Asia-Pacific perspective. I will start by sharing my personal journey with you first. I grew up in the southern part of Taiwan, where 60 years ago is all farmland. Rice, banana, sugar cane were everywhere. By the way, this conference also started 60 years ago when I was 3. Over the years, Taiwan has emerged to become a major supplier of IT products and key components such as notebook PC, networking devices, LCD panels, and semiconductor devices. From my personal experience, I witnessed the benefit of accessing the computing technology, which make people's work more efficient and also daily life easier. It also enabled the economic growth. For all us sitting here, we are among the 2 billion peoples in the world that can have the access of computing technology. But there are another 5 billion peoples in the emerging country that are still not able to enjoy what we have today. In the next 30 minutes, I'd like to share my view on how can we make the vision of connecting everyone happen. I will start with where we are today, where are we going, and how can we make the future technology affordable for the next 5 billion people and provide the unlimited opportunity for everyone in the world. First, reality check. Everyone knows Moore's law is the driving force for IT and the semiconductor industry. The benefit of a new process technology is a 20 to 30% performance increase with 40% lower cost at the same time. Since 1990s, people start to ask the question of how much longer can Moore's law continue. 11 years ago, Dr. Gordon Moore, standing right here at this conference, made a famous announcement, a statement saying that no exponential is forever, but we can delay the forever. Dr. Moore was also humble to acknowledge that Moore was not always accurate, as the wafer size would have been 57 inches by year 2000 per the original 1975 prediction. As we all know that Moore's law has been continued to hold valid until now. Over the last 13 years, the average time for each technology generation is 21 months. So technology advance continues. For that, I think we should give a pat on our back. It was such a difficult job. Well done. Sustaining Moore's law while still have a good profession and make a decent living. Reality check 2. Over the last 40 years, the cost of transistors has continued its exponential decline until recently. While some believe the cost will keep scaling below 20 nanometer, some remain skeptical, suggesting that it will be flattening out. We believe the truth will be somewhere in between, since innovation will drive down costs further. To know how fast has technology advanced, let's take an example of our everyday life's commodity as a contrast. For every 100 grams of rice, the cost is 10 cents in US dollars in year 2013. This 10 cents would buy 100 transistors would buy 100 transistors in 1980, but 5 million transistors in year 2013. So just like rice fits our body, transistors fit our mind. This chart shows the number of transistors being manufactured every year. Last year it was around 10 to the 19 transistors, which means that in average per person we used 1 billion transistors last year. Overall, it's around 60 times increase of the transistor every 10 years. This increase of transistor being used in our daily life is a result of the so-called passive technology market expansion group, where new process technology enabled faster circuit and a lower cost, which enabled system with lower cost or expanded functionality. New software and application was created to run on this system for better productivity or convenience. Pretty soon, the system will run drive on the computation power, which demand to innovation of the next technology node. The positive technology market expansion group has been happening under our nose. Over the last 50 years, from mainframe computer to mini computer to PC, desktop internet, to the most recent mobile internet, every major technology cycle created 10 times more devices and users because of significant low system cost and also expanded functions and applications. Since year 2000, it was also the wireless technology such as Wi-Fi and cellular network that helped sustain this technology cycle. MediaTek entered the mobile SoC business in year 2004, starting from the emerging market. With innovations like dual SIM, better noise reduction, low power technology, to address the specific needs in this region. Last year, there were over 600 million unit cell phones with MediaTek inside shipped worldwide. That was around 30% worldwide total. We will continue to enable the proliferation of the mobile internet access of the world. The impact of mobile access to the emerging country is huge. Studies suggest that for every 10% increase of the mobile penetration, it created long-term GDP growth of 1.2% in the emerging country because of the mobile-based business model enabled economic growth even without good infrastructure. Example like farmers in the remote location can know the up-to-date market demand and pricing information to sell his produce. In Pakistan, the authority used a smartphone to fight the dengue fever, resulting in a 10-time reduction of the infected case. In service, in Africa, branchless banking, such as mobile deposit, mobile payment, is taking off. M-Pesa, a mobile service provider in Kenya, now processes 43% of the GDP of that country. In Thailand, the One Tablet per Child program also started several years ago. The economic growth also created more middle class. The population of middle class was 1.8 billion in 2009. By year 2030, that will be increased to almost 5 billion middle class in the world, with majority of the growth coming from Asia. This new middle class represents the biggest purchasing power as a group in the coming decade. The opportunity to provide the product and service to reach this middle class is certainly a great business, including the mobile service and mobile devices. For the first time ever, most of the people in our planet will be internet connected. We are at the beginning of the greatest revolution ever of the world, and it is all-inclusive. It all started with smart devices. Let's look at how we evolved into today's Cloud 1.0 smart device era. In the beginning, there was desktop PC, which later expanded to notebook PC and many standalone devices, which demand to connect. So infrastructure rises, which further enable internet business. With many users and connected devices, which demand more storage and compute capacity, hence the data center solution. Various internet service businesses like search, e-commerce, social networking first started in the United States, which also shortly started in other emerging countries such as China, with much bigger internet population size. The evolution in the last decade with three major changes in particular: fixed to wireless, standalone to connected, peer-to-peer to many-to-many. For Cloud 1.0, there are three components: infrastructure, client, and connectivity. For client devices, there are many types. We will zoom into smartphone, tablet. Data shows the typical usage of a smartphone are about evenly divided among games, email, web browsing, social networking, text message, and voice. It is a fast-moving world. We all demand instant response when we are gaming or browsing. On the other hand, we also demand the battery to last a few days before recharging. So power efficiency is also critical for user experience. Therefore, for best user experience, we need to optimize both performance and power efficiency. But there has been a fundamental problem to meet this insatiable performance demand. That is, the CPU frequency has been leveled off at around 3 GHz since year 2005. The other big challenge is that the ever-increasing gap between the performance increase and the battery capacity improvement. For this, we need the integrated hardware-software system circuit solution to close the energy gap. Along with the industry, MediaTek worked on enhancing the smartphone performance by using the multi-core CPU and HMP architecture, starting from small energy efficient CPU core to bigger high-performance cores, to the latest octa-core with 4 small and 4 bigger CPU, along with the HMP algorithm to optimize the performance and the power efficiency at the same time. In the picture is one of our customers' products with the MediaTek octa-core SoC inside, and which got the Best Smartphone Award at the Consumer Electronics Show last month. Paper number 10-3 will also disclose MediaTek's technology of PTP, performance, thermal, and power model, to further increase the CPU performance by 23% and reduce power consumption by 30%. Connectivity or communication is next major challenge for the user experience, and this could include several aspects: Wi-Fi with various standards, cellular network of minimal, and various short distance communication such as Bluetooth, NFC, body area network for healthcare-related communications. For the communication data rate, Ethernet, Wi-Fi, and cellular network, the data rate all started to take off since mid-1990s. Wi-Fi will stay at 2 orders of magnitude faster than cellular network. Ethernet will always be a leading indicator of the communication data net technology and also provides a hub for the Wi-Fi. With this increase in data rate, many applications now become possible. For example, since the inception, since year 2008, the download of both apps of both Apple's and Android system hits 10 billion in 3 years. To take other example of user experience, I'd like to take a real-life example. If you are to download a 50 gigabyte, that's a Blu-ray DVD, in year 2000, using the Wi-Fi technology, it would take 2 hours to complete the download. 12 years later, that was reduced to 2 minutes. With cellular network, in year 2000, it would take 1 month to complete this download. That is virtually impossible. By year 2012, that was reduced to 7 minutes. From an energy perspective, at the year 2000, with cellular network, it would take more than 50 batteries to complete this task. That was also impossible. 12 years later, that was reduced to only 3% of a typical battery we are using. So with this improvement of the mobile technology in performance and power efficiency, many applications previously impossible are now our daily life. With that, I will talk about Cloud 2.0. With the foundation of Cloud 1.0, we will migrate gradually to Cloud 2.0 with many wearable devices and much more IoT devices at home, at office, and in a car. The number of radios being used will be increased from 10 per person now to more than 100 radios per person by year 2030. Combined with the processor and the controllers, so for that, this will represent a big silicon business opportunity of over $100 billion. In Cloud 2.0 also emphasizes more on service and easy access. For example, at the office, with Ethernet as a backbone, Wi-Fi will provide a cost-effective way to share the data at home or on the move. In addition to cellular network and Wi-Fi, multiple access to the central cloud. The smart device will act as a personal cloud for wearable and IoT devices. At home, with multimedia content streaming in from the broadband, Wi-Fi will enable the home cloud content sharing between the multimedia cluster and available smart devices. As we move forward, the central cloud will evolve also into local regional cloud and to home personal cloud with coverage everywhere. With this wide coverage, what is the ultimate function of a smart device that the user wants? That is the context awareness function. The use of the context awareness technology was limited in the past because of the availability of the network sources. With the prevalence of wearable and IoT devices, the smart devices can acquire a vast amount of the surrounding information to enhance the context awareness function. As a result, the smart device can provide a true situation-adaptive user experience, such as location-based service, smart healthcare, and transportation service at the right time. MediaTek is also working on various technology innovation for better user experience. In last month's Consumer Electronics Show, we also demonstrated the first multi-mode wireless charging solution with both resonate and inductive technology. We also demonstrate the first smallest form factor and SoC solutions for wearable and IoT devices. One of our mobile processors used in the wearable devices was selected by Lineage Group as the best processor of year 2013. We are also in the ISSCC consortium to keep working on enhancing the system and computing performance. With that, I want to share my 3 dreams in Cloud 2.0. The Dream 1 is a PDA. In addition to the normal PDA function we can expect, I like this PDA to have a true 5-sense multimedia user experience. For example, if I'm ordering a dinner, I can know the taste and smell of the food by click on a device. If you are ordering a coat online, you can touch and feel the fabric from the device. If you are doing the racing game, you can sense the turn and vibration of the road. Dream Device 2. This is a dream device for 5 billion people in an emerging country, for farmers, for students, and teachers. For example, the farmers can use a smart device to study the future market price to decide where and when to plant his crop. Access to various markets to sell his crop at a better price, get his revenue by the mobile payment. At the school, I want to see every student in the school to have access to the internet so that they can always download the best education content, such as Khan Academy, which has a vision of providing free education for everyone, everywhere. For the Dream 1 and Dream 2 realize, there has to be an affordable cloud solution everywhere. This is Dream 3. With continuous help of the Morse law and the communication technology, I can envision the cost of cloud service will go down further 10 times in the future, just like a computer coming from mainframe to PC to a smart device. At the same time, the public cloud will also evolve into various local, regional cloud, which fit local interests, and finally to home personal cloud. Various industry initiatives like OpenStack Foundation, Open Compute Project, and Open Network Foundation all move in this direction. The vision to connect next 5 billion people is also shared by companies across the industry. MediaTek is one of the founding members of the Internet.org initiative with a goal to provide the world of equal access. With that, what is the challenge we need to address to realize the vision? Again, it's energy and power. For energy, we need to have an integrated system, hardware, software solution to close the energy gap. We also need wireless charging for better user experience. We also have to leverage various energy harvest solutions from indoor to outdoor, from milliwatt to megawatt. Bandwidth remains a challenge, so available spectrum is always scarce. So to deliver a reliable connectivity, all the network must be adaptive. So all modulation techniques, regardless of distance or data rate, must work together to provide maximum user bandwidth efficiency. Security. With IoT for mobile health, smart device for mobile finance, and cloud for big data, all aspects of security has to be addressed, like security application system and environment, and also proper mechanism of authentication and authorization, and also a bulletproof data storage to protect from attack. To better use bandwidth and compute resource in cloud service, elastic computing must also be built in. So when latency is of prime concern, the local cloud or the device can resolve that. For big data is required, then the central cloud will provide the compute capacity. To summarize on Cloud 2.0, Cloud 1.0 triggered the smart device era. With many connected smart devices, we will have more wearable and IoT devices and migrate to Cloud 2.0. At the same time, the central cloud will evolve into local personal home cloud. So energy, bandwidth, security, and elastic computing are 4 challenges we must resolve to deliver the 3 dream devices in Cloud 2.0. To bring this all together, Moore's law and passive technology market expansion loop will continue to drive the computing cycle to Cloud 2.0 and beyond. It's upon us to further delay the forever. For Cloud 2.0, we need next wave of innovations to drive down further the cost of cloud service by 10 times for coverage everywhere. The impact of cloud to our lifestyle will potentially be as big as auto industry of the last century. For the first time ever, we are at the beginning of the greatest revolution, and it is all-inclusive. Let's unleash this brand new opportunity for the next 5 billion people, socially, culturally, and in every field of commerce, education, and research. Thank you.